Welcome to the second part of VCAA Math Method 2022 exam paper series. In this video, we will present exam paper 1, questions 5 and 6. Question 5 has two parts, and part A is to solve an index equation, while part 2 is to find the implied domain of a logarithmic function. To find the implied domain, students need to know how to solve quadratic inequalities efficiently based on a given trigonometry function. Question 6 requires students to familiar with various properties of circular functions and their transformations. Welcome to this VCAA Math Method exam paper series. In this video, we will present questions 5 and 6 of Exam 1 2022 paper. Let's start from question 5, which has two parts. Part A is to solve an index equation, 10 to the sum of 3x minus 13 equals 100. Part B is to find the maximal domain of f, which equals logarithm base e of the sum of x squared minus 2x minus 3. As for part A of question 5, since the equation is 10 to the sum of 3x minus 13 equals 100, after being transformed to its logarithmic expression, it is written to 3x minus 13 equals logarithm base 10 of 100, which equals 2. Hence, x equals 5. In part B of this question, since f of x equals logarithm base e of the sum of x squared minus 2x minus 3, x squared minus 2x minus 3 must be greater than 0, which can be written to its factorized form, x plus 1 or in parentheses times x minus 3 or in parentheses is greater than 0. Hence, the maximal domain of f is less than -1 or greater than 3. In question 6, the rule of f of x is 2 times sine of 2x minus 1, and its domain is in the closed interval from 0 to 2 pi. The graph of the function y equals f of x is shown at below. Question 6 has three parts. Part A is to draw the graph of y equals g of x on the above axis, where g of x is the reflection of f of x in the horizontal axis. Part B is to find all the values of k such that f of k equals 0, and the k is in the closed interval from 0 to 2 pi. In part C of question 6, the function h of x equals 2 times sine of 2x then minus 1, where h of x has the same rule as f of x with a different domain. The graph of y equals h of x is translated a units in the positive horizontal direction and b units in the positive vertical direction, so that it is mapped onto the graph y equals h of x, where both a and b are positive real numbers. Part C of this question has three sections. Section 1 is to find the value for b. Section 2 is to find the smallest positive value for a, and Section 3 is to state the domain of h of x. Now let's come back to answer part A of this question. Since g of x is the reflection of f of x in the horizontal axis, g of x equals negative f of x, which equals 1 minus 2 times sine of 2x. Hence, we draw the graph of y equals g of x on the given axis as shown here. As for part B of question 6, since f of k equals 2 times sine of 2k then minus 1, sine of 2k equals 1 over 2, which gives the general expression of k, which equals n pi over 2 plus -1 or in parentheses to the n times pi over 12, where -1 or in parentheses to the n is a switch, which is widely used in mathematical society. Now, we take the value of n from 0 to 3 and the corresponding values of k can be calculated. They are pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12, respectively. Now, we are going to solve part C of this question, which contains 3 sections. The first section is to find the value of b, which is the vertical translation units. Since the transformed h of x is mapped onto g of x, which equals 1 minus 2 times sine of 2x, after being transformed, h of x is written to 2 times sine, open square bracket, 2 times x minus a, or in parentheses, close square bracket, plus b minus 1. Since the transformed function h of x equals g of x, it gives that b equals 2. As for section 2 of part C, since 2 times sine of 2x minus pi, or in parentheses, can be written to 2 times sine, open square bracket, 2 times x minus pi over 2, or in parentheses, close square bracket, which equals negative 2 times sine of 2x. So the smallest value of a equals pi over 2. As for section 3 of part C, since the translation is to move pi over 2 units to the right, the domain of h of x should be moved by pi over 2 units to the left. So the domain of h of x is within the closed interval from negative pi over 2 to 3 pi over 2.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.